Entering video 2 of Slope Week, we are going to take a look at something called Slope-Intercept form. This, like all skills covered during this Algebra summer prep program, is absolutely essential to algebra and future success in mathematics. So now let's take a look at an equation in Slope-Intercept form. The equation on your screen now is in Slope-Intercept form. Equations in Slope-Intercept form result in equations in the form y equals mx plus b, where m represents the slope and b represents something called the y-intercept. In my first video on slope, I discussed how slope represents the steepness and the rate of change of a given line, or how rapidly a scenario is changing. In this case, the rate of change, or the slope, is a positive 3. This means we have a scenario of something increasing by a value of 3 times, maybe per hour, maybe per second, or per some singular amount. Think of slope in this case like a constant of proportionality, but it's not the exact same thing. Because remember, in a proportional relationship, there is a constant multiplicative number, and the equation actually takes the form of y equals kx. So there's no value added on, like in this case there is a plus 4 added on to the equation picture. K, by the way, in y equals kx plus 4, or y equals kx form, is technically the slope. So you guys may not have known that quite yet. So what does that positive 4 do? How is it different from what we've been doing, and what does it represent? Well, the positive 4 represents the y-intercept, which is where a line crosses the y-axis. In a real-world scenario, this is basically referred to as the starting point. So to connect once again back to proportional relationships, what makes these equations different than what we are used to from 7th grade is that not all of these equations result in lines that go through the origin. In other words, equations in y equals mx plus b form, which is slope-intercept form, create lines that don't always go through the origin. In fact, they only go through the origin when b equals 0. In most equations, that's not the case. So we will have a straight line. It will be a linear relationship, a line, but we are starting somewhere most of the time other than the point 0, 0. So let's look at this equation in a table. I'm going to pick random numbers for x and then find corresponding values for y by basically evaluating or plugging in at those x values. Then I'm going to point out the pattern that is present in the table. Now I'm just going to decide for simplicity purposes for x to be 0, 1, 2, and 3. So when x is 0, y ends up being 4. This is our y-intercept. When x is 1, y ends up equaling 7. When I evaluate at x equals 2, I end up with y equaling 10. And when x is 3 and I evaluate, I get y equal to 13. Now we're going to look at this table because there is a pattern happening. Notice that I start at this value of 0, 4, that is our y-intercept, and then from there, and that's what makes it different than the proportional relationship. Remember, proportional relationships start at 0, 0 always. Then from that 0, 4 point, as my x value increases by 1, my y value is consistently increasing by 3. And that 3 comes from the fact that that represents my slope or rate of change. So the equation y equals 3x plus 4 basically means that I start at the value 0, 4, that y-intercept point, and then increase by 3 each time my x value increases by 1. So this simplicity and this pattern is one of the reasons why slope-intercept form is so incredibly useful. It also allows us to easily graph lines. So if I went to graph this equation, I could just create points and plot the points and just connect them, right? But it's even easier than that. So I know my y-intercept is positive 4. So I'm going to go to my y-axis and go up to the point 0, 4. And I'm going to make a point there. Now, from there, I'm going to move over 1 because I know every time my x increases by 1, my y is going to increase or rise, use that term in later video a lot, by 3. So I'm going to move from that y-intercept point of 0, 4, going over 1, up 3, and I am placing a point there. Since you only need 2 points then to create a line, I can connect these points, and I've successfully graphed an equation in slope-intercept form. It is that easy. As you practice, you'll be able to graph equations in slope-intercept form in less than 10 seconds. Now, in terms of a real-world scenario that could be represented by this equation, say you're going and trying to save up for Six Flags. You already have $4, which is our starting point or y-intercept, and you want to save $3 per week until you have enough to go. 3 represents our rate of change. It is 3 every day. This is our slope, which is good. It's what we're talking about a lot here and through this week. X represents the total number of days here, and Y is going to represent the total amount of money you have. Another example could be you have an initial payment of some kind of $4. Maybe it's like a gym membership or something. Maybe it's a subscription service, maybe like a Netflix. So say you have initial payment of $4, and then you're paying $3 additionally each week. X would represent the number of weeks, and Y would represent the total amount of money paid. Maybe we're going to take it to school and talk about studying. Say you've already spent, remember 4 is our starting point, 4 hours studying for your math park exam. And you want to spend 3 hours per week studying. In this case, X remains the number of weeks, but Y now represents the total number of hours spent studying. So we have looked at this one equation as a table, graph, and real-world scenario. Now let's work backwards this time and start with a word problem in order to really understand slope-intercept form. Now don't worry, there's going to be additional videos next week and this week, but mostly next week, detailing how to go back and forth seamlessly between equations, graph, tables, and real-world scenarios. So say your first job is at a local pet store. It's a pretty good gig to start off, where you are tasked to drain and clean a fish tank. This is a large 175-gallon tank, and you attach a hose to the tank to begin to drain the water out so you can begin cleaning. You time how quickly the water is draining, and after 30 minutes, 12.5 gallons have drained from the tank. So to make this simple for yourself, you could double this, because 30 times 2 gets to 60 minutes, which is an hour. So you simply say that you are draining, or the hose here is draining 25 gallons per hour. So let's model this situation using an equation in slope-intercept form. Remember, equations in slope-intercept form are written in the form y equals mx plus b, where m is the slope, which is the rate of change, and b is the y-intercept, or the starting point. Think about this scenario here. We have water draining from a tank at a constant rate of 25 gallons per hour. We also know that there was 175 gallons of water in the tank before you did anything, before you started draining anything out of the tank. So I think, from my perspective, it's actually easiest to identify our y-intercept here, which is positive 175, because that's where we started. That was the amount of water at the beginning. So instead of b, we can swap that out and put in 175, since that is our y-intercept. That's where we started. Now, water is draining from the tank, okay? Therefore, the rate of change, or slope, is negative. Therefore, the value I'm going to put in for m needs to be negative. In this real-world scenario, I should place a negative 25 in for m because the water is draining at negative 25 gallons every single hour. So we are left with the equation y equals negative 25x plus 175. And we have finished writing the equation in slope-intercept form. But it's important before we move forward, we define our variables anytime we write an equation. In this situation, x represents the number of hours, whereas y represents the gallons of water remaining in the tank. We can now take this equation to either a table or a graph. I'm going to choose to do a graph first, but as you practice, you'll improve in your ability to quickly transition between these different forms. So in this graph, my starting point, or y-intercept, is 175. Therefore, I'm going to put a point at 0, 175, right on the y-axis above the origin. My slope is a negative 25, I know from the previous video that this means my line should be decreasing because we have a negative slope, meaning the line should be going down rather than increasing. Specifically, it should decrease by 25 each time I move over 1. I increase my x value by 1, my y should go down by 25. So I know if I go over or run 1 spot to the right, I need to go down 25. If I do this, my second point lies at 1, 150. Now I can now connect my 2 points and create my line to represent this linear relationship. Last but not least, I'm going to take this to a table. I already know that I have the point 0, 175 and 1, 150 from graphing, so let's not rework the wheel. We already have those 2 points. I also know that based on my equation and situation, my y value simply goes down or decreases by 25 for every increase in x. So this makes my next point 2, 125, then 3, 100, and then 4, 75, and so on and so forth. We have now taken the real world scenario and written an equation in slope-intercept form. We have graphed the equation, and then we modeled the linear relationship in a table. I promise this will get easier the more and more you guys continue to practice. But after watching this video, I want you to first and foremost understand that equations in slope-intercept form create straight lines and are written in the form y equals mx plus b, or m is our slope or our rate of change, and b represents the y-intercept or our starting point. In later videos and through various assignments and additional practice, you will become more comfortable with working with slope-intercept form equations. Keep working hard and reach out to me if you need any support.